All right. There it is. All right, so a couple things. If you didn't get this, if you missed lab, stop doing that. You probably want to get one of these two before you leave. Don't come up here right now. The chapter 11 practice sheet. So that's what I just gave back. Was that? I looked at that, marked it up. We'll talk about that in lab if you want to. I want to remind you about this. I put this up here a while back. We talked about the discriminant before. So guys, when I ask you, tell me what kind of answers some quadratic equation is going to have. I don't want the answers. I don't want that. So if you get them, you'll lose points, which is weird, but oh well, too bad. You need to understand, guys, that the most important part of this in a way is that b squared minus 4ac that controls a lot. Will there be two answers? Well, it depends on if this is 0 or not. What kind of answers will they be? It depends on if this is less than 0 or greater than 0. Or equal to 0. So these are the situations you could find yourself in. And all you got to do is look at this. Why do I not care about the square root? And why do I not care about the rest of this stuff? Because if the thing inside the root is negative or positive, it changes the kind of answers. So we're not solving, we're not doing something magical to make this become this. We're just looking at the inside of the radical because it makes sense. I'm not doing anything algebraic to it. I'm just looking at what makes sense. Conceptual idea. Okay. So any questions about that discriminant dude? The instruction will be very clear. I'm not going to say use the discriminant necessarily. I'm going to say don't solve this. Just tell me the type and how many answers. So if you start to solve it, you should go, wait a minute, he said don't solve it. I'm doing something wrong. I better stop. All right. Let me see. Oh, another thing that I want to make a really, really big point of right now is completing the square. My hands are going to warm up before I can approach my semi-legible instead of completely illegible writing. What does completing the square require to be true? Anybody know that took that lab last week and now understands what has to happen in order to start using it for a quadratic equation? What's got to be true?
It has to be 1 in front.
1 in front of the x squared, 11. Because of the way it was developed, it assumes that that's true. So if I have a problem, let's say, for example, this would be a good example, get us back up to speed here. If I had this beautiful monstrosity here, 3x squared minus 2x plus 9 equals 0. And I said, use completing the square. Now, if I say use completing the square and you use quadratic formula, I don't care if the answers are right or not. You're going to lose almost all the points, if not all of them, because you didn't do what I asked, right? That should make sense. Why? How do I know this doesn't factor? What would be the first step in trying to factor this? Just to kind of point out why we have other methods. What would be the first step in trying to factor this guy? 3 times 9, 27. Any factors of 27 that add to be negative 2? I don't know. It's not going to happen, right? All right. So that's why we have other ways of solving this because before that's all I could do. Now I want to know, how do I solve more general things? There's got to be, in fact, how many solutions must there be to this? 2. Totally. Or you're just going like, these two. Oh, really? That power tells you how many answers. Now they could be repeated, they could be real, they could be complex, but there has to be 2 total answers. So if it was x to the 847, there would be 847 answers. Holy shit. Alright, now, so it's not going to factor. I don't want you to factor it anyway. So the very first thing I should do is what?
Divide by 2.
Divide by 3. So we got x squared minus 2/3 x plus 3 equals 0. These are all try to be 3's, by the way. 4 little dudes. Malformed clone 3's. Alright. Now, you quell the trepidation, boiling up inside about the fact that there's a 2/3 in this thing. You go, alright, me, calm down. What do I need to do before I start doing completed square? I need to make make space. So I better subtract 3. X squared, bless you. I got space to work with. Now, she has like, just divide by 2. Alright. The first step now, now everything's in place for completing the square. I got a 1 here. I made space. Let me just stop right there. Is everybody decent with me so far? I mean, this is just setting things up so the completed square can actually work. Yeah, so now, here's what really, really freaked people out. What is the middle term, the middle coefficient? Negative 2/3. And I got to divide that by 2. Now, I had some neat people that just made that multiply by 2. That was neat. Right, I think I said that's the math equivalent of water into wine or something. It'd be really useful. But how do I divide by 2? Multiply by 1/2. Yes, there you go. Multiplication by half is the same as dividing by 2. So what do I need here? Yeah, you get negative 2/6, which reduces negative 1/3, or you kill the 2's to begin with. And then the second step is take whatever I got and square it. 1/9. Let me see if I can get all fancy. What do I do with this? That's what I add to this to make it work. I add 1/9. Add 1/9. Now that looks really gross, but why do I not care about the factoring step at least? How does that guy factor? How does this guy factor now? X minus 1/3. The very first thing you do tells you how it's going to factor. The second step tells you what to add to make that happen. Why? Because we looked at the pattern and we saw that's what happened. That's what a lot of math is. We look at the pattern and we develop a process based on it. It's not magic shit, right? It's just that's what always happens. So I put minus 1/3 squared. Now what do I have to do on this side? LCD. Multiply by 9. So you get negative 27 plus 1. Alright, let me stop there for a second. Here's the whole problem so far. We're not done, obviously. Now, believe it or not, some of you guys don't believe this, but sometimes completing the square is quicker than quadratic formula. Most of the time, quadratic formula is quicker than, because quadratic formula is a shortcut. It doesn't always become a shortcut. This one, it would definitely have been a shortcut, but too bad for you. I said complete the square. What do I do now?
Square root.
Square root. So on this side I get, what's the square root of 9?
3.
3. Plus or minus, right? And what do I have on the top? Yes. Square root of negative 1 is I. Square root of 26, I don't know. I don't know why I got so small there. There we go. Square root of 9 is 3. Square root of 26, I don't know. Square root of negative 1 is I. And then one last step. Yeah, add the 1/3 in there, and you get x equals 1/3, give or take, I rad 26 over 3. Wow. Cool. I like it. All right. So there's always an idea behind something, and then there's just the nuts and bolts of how to do it. This is just brute force, using a beautiful idea based on patterns we saw by just foiling shit out. And we saw patterns, we made it this beautiful idea. Now that we got the idea, we just brute force that sucker. Complete the square says, if it looks like this with a 1, I'm gonna do stuff, I'm gonna work. So then we just brute force that sucker. It's crazy. We did it with freaking A, B, and C in there. That's where a quadratic formula came from. All right. Now that I've given enough time for everybody to hear, let's talk about the test for a second before we get back into other stuff. Test, whatever hell number, I don't know. Is it 4 coming up? Holy shit. This semester is going. Test 4 is scheduled for Thursday, but I would really, really enjoy being able to move it to Tuesday. Next Tuesday. You're funny. You're funny. Not tomorrow.
I like that. That's a great idea.
That's awesome. You guys understand what's happening?
Excellent. What's that date?
Say again?
Date?
The date? I don't know, a week from tomorrow. What is today?
The 23rd.
23rd, yeah. Today's the 16th, the day after the 15th, which is important. So it'll be the 24th day. It'll be a week from tomorrow. Test 4 moved to Tuesday. April, I believe, 24th. Does that sound good? Everybody all right with that? All right. So you always ask the follow-up question, well, what else changes? Now we have time for quiz on Wednesday and Thursday's lab. What will it cover? I don't know. I'll tell you tomorrow. Obviously, the first part of chapter 11. But I'll figure out exactly which sections. You guys with me? So review day will now be next Monday. I'll give a practice test out towards the end of this week. Okay. All right. Any questions about that? Yes. Say again? This, yeah, so that it's preparing you for next Tuesday's test. Okay, yes. Like I said, I'm not going to look at it. I'll tell you tomorrow. Just want to make sure nobody had a big opposition to this, and then I can spring this on you. All right, and just to remind you guys, today, I brought calculators with me, but in the lab today and tomorrow, it's going to be like an intensive calculator workshop. We're going to talk a lot about stuff to do in the calculator. Yeah.
So is the homework going to be postponed as well?
Yeah. Homework is always due the day of the test. So if I move the day of the test, homework date gets moved. Somebody remind me to do that in my math lab. Please. Thank you. If you don't, oh well, it's on you.
Yeah. Well, that's great because I don't have to be behind on the test or anything like that. I'll have time to finish the homework and memorize
Exactly.
everything.
Yeah, appreciate that. Good. Okay. Yes.
Does that mean that the homework due date changes, or is it still gonna be?
That's all right. Yeah, just said. Yeah, the homework date will change, and I asked if somebody would remind me to do that. Yeah. Cool. Okay. All right, so let's get back into some other stuff here. I think that discriminant was the very last thing we talked about last time, right? Oh, that's not true. Here, let's do this. Let's do an example that's a little freakier. We did that the ones where you had to do the U substitution. Remember U substitution? U sub for short. Let's do an example of this. A little bit different. Let's see. Well, let's do a normal one, and then we'll do a little bit different one. Yeah, okay. I like it. Oh, this is yummy. Oh, man, you guys are going to like this one. Oh, shit. How many answers should there be to this? 6. We got to find all of them. Yay. Get your little Pokeball and we're going to catch them all. Catch them all. Now, some of you guys might not have to do this. Let me do the U sub, and then I'll kind of do it again without U sub. In fact, let's try to do it without U sub. What would x to the 6th be broken up as? And you guys see why this is going to work. Why does this power have to be half of this power? Because the first thing I do with this thing is cut it in half. And where's the middle term come from? That number times this and that number times this. So the middle has got to have half of the power that this does. Yes, ma'am?
Is there like some situations where the middle is not half of the...
Exactly, and that's what you'll learn how to handle if you take pre-calculus. Or maybe even here. We'll see. Sorry. That's what passes for dancing for me. So how do the numbers work? The numbers don't give a shit what's going on with the powers. Yeah, -8 plus 1. Now, do you guys notice something about each of these? Yeah, cubes. Well, this guy's going to have a little dude, big dude. This guy's going to have a little dude, big dude. Now you start to see where those 6 answers are coming from here. See if we can do this semi-quickly. So I'm going to put what here? X minus 2. I like it. So the other 2 x's, the other 2 2's. 2 times x, change the sign so it can cancel shit. All right? Same thing here. Yeah, 1x plus 1. The other 2 x's, the other 2 1's. 1 times 1 is 1. Change the sign. 1 times x is x. What 2 answers can you just see right now? 2 and -1. What do I have to do with these guys to figure out answers from them? So we got those 2 answers from those little parts. These big guys cannot factor. So what do I have to do to solve them? Quadratic formula. Or if you just are in love with completing a square, which is fine with me, you can complete the square. So why don't you guys do that? Both of those. Quadratic formula those. Just to verbalize that phrase. Or as always, you can draw a duck. At least make it look like you're doing something. Cool, right? Just throw stuff in, throw stuff in. Okay, negative 2 plus or minus 4 minus 16 is negative 12. What can I do with the negative 12? What's the square root of negative 1? I. 4 times 3, right? So square root of 4 is 2. Square root of 3, I don't know. So that's going to be negative 1 plus or minus I rad 3, because I can reduce both of those. There's 2 more answers right there. So you got 2 real answers, 2 more complex answers. That's 4 total so far. I know some of you guys are out there going, this is one problem?
I have a question.
Yes.
I'm not understanding the 4 times 4 equals 36, but, well, I understand that part, but right below it, we have negative 12. I don't know how you got that.
Oh. 4 minus 16.
Oh, right? Yeah. Right.
Yeah, it's always, when there's so much going on, it's easy to miss little things like that. What about this guy? What do we get inside here? You get 1 plus or minus, 1 minus 4. Yeah, negative 3, so I get I rad 3 all over 2. So 1, 2, 3, 4, 5, 6 answers. As we know there should be. Oh, shit. Factoring cubes should be easy now. Just because we're out of the factoring section does not mean you're never going to have to factor again, like some of my calculus students seem to believe. Rawr. And then quadratic formula, you need to just be able to plug stuff in. Now that was what I termed normal use of it. Let's look at ones a little bit different. You guys all cool with this? Everybody got this?
Not quite.
Okay. Okay, so what about this guy here? What you got, Jeff? Let's see. Sure, no, let's do that. Yeah, let's do that. Now, on first glance, this looks like, isolate the radical. You can certainly solve this way. But if I say solve by using u sub or something like that, then obviously you can't do that, right? How would I rewrite radical x as a power? What's the power look like? So the power on the middle guy is 1/2, and the power on the first guy is 1. So is the middle power half the first power? Yes, there you go. So it's in quadratic form. It's quadratic in form, right? All right. Now here's how the u sub works. Let u equal the middle dude. We just verified that the middle guy's power is half the first guy. So if I double the power by squaring this, what happens to this? X. So if I let the u be this will automatically be u squared, because I verified that the middle one was half the first guy. Okay. So how can I rewrite this now so it looks a lot better for me? X is u squared. X to the 1/2 is u. And 28 is still 28, thank God. All right, let me let you absorb that. This is really a strange step for students because, for one thing, it feels like and really, what have we done? Nothing. We just wrote it in a better form to highlight that it is quadratic in kind of like nature. The middle guy is half the first guy, so we just made it really, really, really in our face about it. So this isn't different from that, except that this is a different unknown. They're both unknowns, but this unknown is x to the 1/2, so then I can use it. Now I can solve this for u, but I can't stop there because the original question is all about x. So how do I keep going with this equation? Pretend like that's what I gave you. I said solve for u. What would you do next? Please, dear God, yes, factor it. If somebody's out there saying quadratic, why do that to yourself? This is very easy to factor. How do you factor this? So u is either 7. I like it, right? Back in the day, we would stop there, but now we know we can't. What was u? What do u be? Yeah, u was the square root of x, really, right? So if I solve this, what do I get? How do I solve this? Square. I get x is 49. Now what happens here? I could square it and keep going, but why shouldn't I do that? Square root cannot be negative. Doesn't lead to any answers. It's not even complex. It's just that this symbol is the positive root. So I can't be a negative number. So that doesn't give me any answers. So x is 49 is the only answer. Let's see if it works. What's the square root of 49? 7 times 3. 21. Take away from 49 is 28. Minus 28 is 0. Yay, it works. All right. You guys really like that one. Okay. All right. So, in a little bit of time I got left, let me give you this. This is related to what we're going to do today and tomorrow in the lab. This from 11.6. I would love it if you guys were sitting next to somebody paying no attention and I start passing something out and you just go, hey, it's a pop quiz. What? Continuing. This is 11.6. This is where we really get into graphs. And we're going to use the graphing calculator, but I'm also going to show you a lot by hand. Because hopefully you picked up from me that old school, like to actually learn shit. So a couple things about parabolas. Can we let's do this before I start talking about this. Let's graph this sucker and find these things on the graph, and then we'll graph this, and then we'll call it a day. All right? There's a whole other side to this, but we won't worry about that yet. So help me out. To graph f of x equals x squared, you can make a little table of values. We already know what this looks like by now, but let's just really get the details. Negative 3 squared is 9. Please don't say negative 9. Negative 2 squared, 4. Negative 1 squared, 1. 0 squared, 0. And then it's going to repeat because it doesn't care if it's positive or negative. It comes out the same. So 1 squared is 1 again, 2 squared is 4 again, 3 squared is 9 again. That's really numerically why it's got that whole, and now I'm going back, it's got that shape to it. So if I plot all these things, negative 3 goes to 9. Whee. Negative 2 goes to 4. Plot. Negative 1 goes to 1. 0 goes to 0. 1 goes to 1. 3 goes to 9. So even though my drawing is always a little questionable, can you guys tell me where it looks like there was a mirror placed? On the y-axis. And so that would be what's called the axis of symmetry. Right? Not the axis of evil. Not the axis of evil. That's the axis of symmetry. That's sort of like the name we give to where the mirror would go. So there are graphs that have different axes of symmetry, and there are some graphs that have no axis of symmetry. The parabolas always have an axis of symmetry that runs through what I would consider the most important point. What do you think the most important point is on that parabola in a sense? Yeah, and what happens at that 0, 0? That's where the graph does what? we're going this way, no we're not. So that's where the graph turns. So remarkably enough, math people are very creative. We said, let's call that the turning point. So this is called the vertex, but it's also called the turning point. Yes, sir?
Can there be different vertices?
Vertices, yes. So there are things we call vertices, like when we get to conic sections. Oh, shit. That's where we talk about ellipses and circles and hyperbolas. There are things we term vertices because they are turning points. But like an ellipse would have 1, 2, 3, 4 vertices, right? We actually consider the ones with the long line, we call those the vertices. Does that kind of make sense?
Yeah.
So the IT of a vertex has got to be sort of like the turning point somehow, or the max or the min. So another way to look at this, is this a max or a min? It's a min. So where does the min occur, or the max, if it opens down? At the vertex. Will the vertex always be here? No. So it's wherever the vertex is, that is where the max or min happens. So in this case, this would be a min. Min of 0 at x equals 0. That's the official way to say that. So tell me, what's the vertex exactly? 0, 0 for this problem. I like it. And the axis of symmetry, oh shit. Can somebody give me the actual equation for the axis of symmetry? Oh, really? What kind of things go straight up and down? What are their equations? No. X. If it's straight up and down, it's not moving left or right. So what's not changing? X isn't changing. So the equation is X is this. What is Y doing? Everything. Y is every damn thing. So this would be X equals 0. So the vertex went through 2, 1. The axis of symmetry would be X equals 2. So let's try one more out. Took about 5 minutes. Let's take about 5 minutes. Perfect. I'll do this with you guys. So now we're doing this. Let's see what we get when we plug a negative 3 in. We get negative 3 minus 1 squared minus 2. Somebody help me out. Yeah. Negative 3 minus 1 is negative 4 squared is 16 minus 2 is 14. By the way, when you make an XY table, you do not have to plot every point you get. You make a bunch of points and pick the best ones. As long as you know what the shape is, you're good. Negative 2 minus 1 squared minus 2. Yeah, this will be 9 minus 2, 7. Negative 1 minus, get out of there, parenthesis. Negative 1 minus 1 squared minus 2. Oops, get out of there, 0. This will be negative 1 is negative 2 squared is 4 minus 2 is 2. When I plug a 0 in, 0 minus 1 is negative 1 squared is 1 minus 2 is negative 1. So are you with me? I mean, I'm going a little fast, but we're just plugging shit in, right? Not hard. When I plug a 1 in, 1 minus 1 is 0, squared is 0, minus 2 is negative 2. Now, do you see why 1 is a very important point here? 1 as a value of x. Why is 1 a very important value? It makes this be 0. Now, what happens when I make it 2 now? What happens? 2 minus 1 is 1 squared is 1 minus 2 is... Do you see how it's going down, and now it starts to go back up? So then what must this be? It's going down, and then it goes back up. That must be the vertex. Shit. All right. See, so it's not always a 0, 0. If I plug other stuff in my equation, it's going to move the vertex around. And when I plug a 3 in, 3 minus 1 squared minus 2 is 2 squared is 4 is 2. So I can plot every point on there except that first one. Just forget about him. Go away. So let's see. I get a point negative 2, 7. Negative 2, 7. Plot. Negative 1, 2. Negative 1, 2. 0, negative 1. 0, negative 1. 1, negative 2. 1, negative 2. 2, 1. 3, 2. 3, 2. There you go, Jeff. We didn't do it, but I'll bet you anything that 4 goes where? Yeah, 4's got to go to 7 because of the mirror image. That axis of symmetry. It's really nice. Where is the axis of symmetry? That is the, so negative 2, 1 is the, yeah, they're negative 2, 1.
No,
1, negative 2 is the, what's 1, negative 2? That is the vertex. So where's the axis of symmetry? What's the equation for the axis of symmetry? Can you draw it in? X equals, no, x equals 1. That's y. So the axis of symmetry would be x equals 1. Craziness. Can you guys see the x-intercepts? They're right there and there, aren't they? I bet you anything they're not pretty. Right? Okay, so we'll talk about in lab today, we'll actually talk about how to get those values, those intercepts. I'll see some of you guys in a few minutes in the lab.